Hey everybody, these are some notes that we talked about on Wednesday 127 if you're in cohort A. If you're in cohort B, this is what we're going to be talking about on Thursday, January 28th. So if you missed class and you need kind of a little rundown of what we did, this is gonna be it. So you want to put these in your notes. If you were in class, you could probably skip over this section of the video and jump into some homework examples, which I'll be later in this video. We're going to start here by just kind of exploring some side ratios in a 30, 60, 90 triangle. Now there's a little bit of new language, but I'm going to try to build the concepts for today on some stuff that we already know. Okay, so let's start out with what this idea of a reference angle is. Okay, a reference angle is just an angle that you pick to use as a reference for labeling. Okay, so in this case, this would be the 30-degree angle, and this would be the 60. So I would probably want to label my my sides based on this reference angle. Okay, we're going to do that in just a second. Before we get too far with that, let's see if we can remember what the side lengths of this 30, 60, 90 would be. Okay, let's say that this side is 1 unit. Okay, well remember from our 30, 60, 90 special right triangles lesson that the hypotenuse is always double the short leg. Okay, and then we also know that the long leg is always root 3 times the short leg. So this would be 1 times root 3, which would be root 3. Okay, so those are the ratios in a 30, 60, 90. Those are the side lengths in proportion. Okay. Now I've been using terms like short leg, long leg, right? Well, what we can do is we can pick an angle and we can use that angle as like a labeling scheme for the rest of it. Okay, so what I'm going to do is I'm going to circle my reference angle, okay, and then I'm going to draw a line directly through that angle. So it's going to go all the way across. Okay, this arrow will point to what we call the opposite side. For this reference angle, for this angle, this is the opposite side. It's like across from it. Okay, so in this context, opposite means across from. Okay, so this side I'm going to label as the side opposite the 30-degree angle. Okay? Now this guy right here, this side, notice it's actually forming part of the 30-degree angle with the hypotenuse. Right? So this side, it's not across from the angle, it's actually next to the angle, or really it's a part of the angle. And so in reference to this angle, if this is the angle we're talking about, we would call this side over here the side adjacent to the 30-degree angle. So side adjacent to the 30-degree angle. Okay. Now this side, of course, is called the hypotenuse. That doesn't change. The hypotenuse is always the hypotenuse. It's always the one across from the right angle. So this we're going to call the hypotenuse. Okay. What we're going to do now is we're going to just write the ratios of the sides of this triangle. Okay. We already kind of know these are like the side lengths, but let's write some ratios. So what I want to see is I want to see for a 30-degree reference angle, what are the side ratios? What, I guess I should say, is the ratio of the sides? Okay. Again, we have to pick a reference angle so we can say opposite, adjacent, and we know what those mean. So let's start out by finding the ratio of the side opposite to the hypotenuse. Okay, so in reference to this 30-degree angle, this is the opposite side, right? Opposite. Over the hypotenuse, we're comparing these two lengths. The ratio of those two sides, opposite to hypotenuse, will be 1 to 2, right? In other words, the hypotenuse is 2 times bigger than the side opposite of the 30-degree angle. Okay, and this is all based on the 30-degree angle. Okay, we also might want to find the adjacent, the ratio of the adjacent to the hypotenuse. Okay, so here's the adjacent, the side adjacent to 30. Here's the hypotenuse, right? That would be root 3 over 2. Okay, and so now we've compared, we know the ratio between these two sides. We know the ratio between these two sides. Or excuse me, these two sides. Sorry, you can't see that. These two sides. Now we just need to find the ratio between these two sides. Oh, sorry for my fingers. I got markers all over them from teaching all day. So that's just, you know, a sign of a job well done. Okay, we have one more comparison to make. We haven't compared the opposite to the adjacent yet. Okay, so if we want to compare opposite, or the ratio of the opposite side to the adjacent side, okay, that's going to be 1 over the square root of 3, or 1 to the square root of 3. Okay, now of course we need to rationalize this, so we're going to multiply it by root 3 over 3 to get root 3 over 3. So 1 times 3 is root 3 times root 3 is just a regular 3. So this is, you know, the fully simplified ratio there. Okay, now again, not anything too super new just yet, but this is actually true. These ratios are always the same no matter how big this triangle is, right? I did like a 1, 2, root 3, but we could scale this triangle up. So if we did that, let's take a look at what that would be. Just going to draw a bigger one here. This is probably not totally to scale, but get the idea. Okay, let's scale it up. Let's scale it up by a factor of, let's say, 15, okay? So that would mean this is 15 because it's 15 times 1, right? And this would have to be 30 because it's 15 times 2. And this one here would be 15 root 3 because it's 15 times bigger than that one. So I'm scaling up all my sides by a factor of 15. Okay? Again, if this is my reference angle, this is still the opposite. I'm going to label that with an O. This is still adjacent. I'm going to label that with an A. And this is still hypotenuse. I'm going to label that with an H. So if you look at these ratios, what's the ratio of opposite to hypotenuse, right? Opposite to hypotenuse, it's 15 to 30, or 15 over 30. But that reduces to 1 over 2, right? So it doesn't matter how big this triangle is. The ratio of opposite to hypotenuse for a 30-degree angle in a right triangle is always going to be 1 to 2, this side to this side, right? Okay, if we look at the adjacent to hypotenuse, that's 15 root 3 over 30, right? But 15 root 3 over 30, the 15 over 30 simplifies to 1 over 2. So I have 1 times root 3 over 2, or root 3 over 2, right? It's the same ratio. Okay, and the same is true for this guy. If I want the ratio of the opposite side to the adjacent, right, opposite to adjacent will be 15 to 15 root 3, or 15 over 15 root 3. Right? The 15s are going to cancel. You're going to get 1 over root 3. When you rationalize 1 over root 3, you're going to get this again. Okay? So this is kind of how proportionality works, right? For every 30, 60, 90, the ratio of the sides are going to be the same. If I blow this triangle up and I'm looking at a 30-degree reference angle, the ratio of sides for that 30-degree reference angle will always be the same. There's actually a special name for these ratios, okay, which is going to be our next piece here. Okay, so let's go ahead and talk about trig ratios. Okay. Trig is short for trigonometry, and trigonometry is a whole branch of math. In fact, you're going to take a trigonometry class your senior year at UCAS in your first semester, and then your second semester you're going to take calculus. But trig is a whole branch of math that's just based on right triangles alone, and we're just kind of dipping our toe into that. And the trig ratios are these guys. We're talking about these 3 ratios. Okay. Opposite over hypotenuse, that ratio has a special name, and that name is sine. Okay, S-I-N-E. Okay, so the sine for some reference angle is equal to the opposite over the hypotenuse, the opposite side to that reference angle over the hypotenuse. Okay, now there's a special symbol that we use for like a variable for angles. Okay, and it's called theta. It looks like this. It's like a 0, looks like a 0 or an O, but it has like a line through it. It's actually a Greek letter. Okay, theta. But it's just a variable that represents your reference angle, whatever angle you're talking about. In this case, we're talking about a 30-degree angle, but it doesn't have to be a 30-degree angle. So the sine of any angle, now it has to be a right triangle, but in any right triangle, the sine of that reference angle is the ratio of the side opposite that angle over the hypotenuse. Okay? On your calculator, you're going to see a key that says sin. It's actually not sin, it's short for sine, so you pronounce that sine. And it's that trig ratio. Okay? There's another one that's called cosine. Okay? Its abbreviation on your calculator is COS, cos. It looks like cos, kind of. Okay? The cosine of some reference angle, whatever angle you're talking about, 30 degrees, 60 degrees, whatever, 17 degrees, it doesn't matter, is the ratio of the side that's adjacent to that angle over the hypotenuse. Okay? And then there's one more, and it's called the tangent, and that's this guy, right? So sine, cosine, tangent. Tangent is the name of a ratio of sides. Okay? You have to have a reference angle, some angle. In this case, we're talking about 30 degrees, but it can be anything. Okay? And it's the ratio of the side opposite that angle over the side that's adjacent to that angle. Okay? And its short kind of nickname on your calculator is tan. Tan for tangent. Okay, so we basically already kind of talked about sine, cosine, and tangent. We just didn't have that language, right? So how you would write that with the new language is you would say, like for this, for this reference angle 30, you would say the sine of 30 equals, and it would tell you, or you would say basically 1 over 2, right? For a 30-degree reference angle, the ratio of opposite to hypotenuse is 1/2. So this guy right here and this stuff right here, okay, is just abbreviated this way. For a 30-degree reference angle, the ratio of the opposite side to the hypotenuse is always 1 to 2. That's what this means. It's a lot of information packed in there. That's why we wrote it up here. Okay, let's do cosine. Same idea. So cos of 30 is a lot of kind of ideas crammed into like a little piece of information. It's saying for a 30-degree reference angle, the ratio of the adjacent side to the hypotenuse will always be root 3 over 2, regardless of how big the triangle is. Okay? And then tangent here, same idea. So tan 30, okay, the tangent for a 30-degree reference angle, the ratio of opposite to adjacent is root 3 over 3. Okay, pretty cool. So that's just some new notation, some new ways of thinking about the same triangle. Okay, I want to show you something that's kind of cool. This is like your calculator, class set calculator, and if you don't have a calculator, you don't need to have a calculator. You can use the internet. There's a lot of cool calculators. The one I like is on Desmos. So if you go to desmos.com/scientific, you'll get a calculator that has sine, cosine, tangent, and I'll link that in the assignment description here in just a second. Sorry, my lights went off. Okay, so what I want to show you is that your calculator has these ratios stored. So check it out. I'm gonna type in this stuff here. So if I go sin, see that sin? That's sine. Sine of 30 degrees. Cha-ching! 1 over 2, right? It knows. Your calculator knows about this right triangle. It knows the side ratios. You have them memorized now, but your calculator has them too. Okay. What if we did cos? Cosine of 30, right? What is the relationship, what is the ratio of the adjacent side to the hypotenuse for a 30-degree angle? Root 3 over 2. Cha-ching, cool. All right, what about tan? Okay, tan of 30. Better be root 3 over 3, right? Boom. So your calculator has these stored, okay? You might be thinking to yourself right now, what the heck, Mr. Lowry? Why did you make me memorize them when my calculator has them stored? Well, like we talked about, the triangles, the 30, 60, 90, and the 45, 45, 90 are so common that it's nice to know those relationships without having to use a calculator. It's nice to just know them. Also, it kind of helps us build as we go. We can use this 30, 60, 90 as like a jumping off point for all the other right triangles, okay? So the big question is, what about other triangles, right? We're talking about the 30, 60, 90 because this is the one we're familiar with. But we have to talk about the other ones. So what about all the other right triangles. There's more than just 30, 60, 90. There's more than just 45, 45, 90. There's all kinds of angles. Well, the good news is your calculator's got you covered, right? I'm going to make you know the two special right triangles because those are pretty common to know. But let's say you have a right triangle with an angle that has 17, right? So let's say you have like it would be 17, 73, 90 or something like that. Your calculator will tell you the ratio of those sides. Now, it doesn't always give you exact values. It has some of them stored as exact values, but sometimes you'll get a decimal, but that's okay. I'm going to show you how to use those. So we use the calculator and the trig ratios, sine, cosine, and tangent, to get side ratios in every other type of right triangle. Okay? So let's draw another right triangle, and let's take a look. All right, so I'm just going to do one. I'm going to do one in just like any kind of random orientation. Do just kind of a funky one. Okay, this is the right angle. And this is kind of a small angle, right? And this is kind of a big angle. So let's say that this is, let's say 75 degrees. Okay, that's kind of a funky angle, right? And let's say that, now if you think about it for a second, every right triangle that has a 75-degree angle will also have a 15-degree angle as well, because they have to all add up to 180. So this is a 15-degree angle. I'm not going to measure it, or I'm not going to label it because that's going to kind of throw off some of our labels here. But just so you know, this is going to be a 15, 75, 90, right? We could label it up here just for fun. So 15, 75, 90. Okay? Now we don't know the side ratios of these. We don't have them memorized, but the calculator's got us covered. So what we would, and also, sorry, one other thing. Every 15, 75, 90 right triangle is similar to every other 15, 75, 90 right triangle by angle. And so the side ratios are the same no matter what the lengths are. So we can pick any length and we can end up finding, other missing lengths. So let's do this. Let's say that this guy right here is 10. This side length is 10 long. Okay? And let's say that this guy is x, this is an unknown, and this guy is a y. Okay? We're going to practice just like setting up some ratios here. Okay? So when we're setting up trig ratios, the labeling is actually really important, the way we label this. So here's what we're going to do every single time, and I want you to do this on your homework. Circle the reference angle. Okay? The angle that's given that's not the 90-degree angle. Okay? Everything's going to be labeled in reference to this angle. Okay? Let's draw an arrow through that angle. Okay, and that is going to point to the side opposite that angle. So I'm going to label this O for opposite. Okay, that's the side opposite 75. Okay, this guy right here is the hypotenuse. It's across from the 90-degree angle. So I'm going to label this H for hypotenuse, which makes this guy the adjacent side. Okay, so knowing how to find the opposite, the adjacent, and the hypotenuse in a right triangle is crucial for your homework. Okay. So I have 3 different trig ratios. Let's see if we can set them up. Let's start with sine. Okay, so the sine of the reference angle. Okay, sine 75. Well, if we go back and we think about what does sine mean, okay, sine is the opposite over the hypotenuse, right? So we go back here and we look for opposite over hypotenuse. Opposite over hypotenuse, or sorry, opposite of hypotenuse. So sine of 75 would equal x over y in this case, right? The ratio of those two guys. Okay, now our calculator will actually tell us what sine 75 is, and we'll use that in just a second. Okay, let's do cosine for a sec. Cosine of 75. Okay, going back to our trig ratio, cosine for any angle is the adjacent side, the side adjacent to that angle over the hypotenuse. Okay, so it's adjacent over hypotenuse. It would be 10 over y. Okay? And then the tangent of an angle is always the opposite over the adjacent. Okay? So it would be x over 10. Now you might be thinking right now, how am I ever going to remember all this stuff? Well, there's actually a mnemonic that will help you remember it. It's kind of a weird sounding word, but a mnemonic means memory device. The mnemonic is SOH-CAH-TOA. Looks like this. SOH-CAH-TOA. Right. So it kind of sounds like suck a toe. Sounds kind of weird. But SOH-CAH-TOA. Right? What does it mean? So sine is equal to the opposite side over the hypotenuse. Cosine is equal to the adjacent side over the hypotenuse. And then the tangent is equal to the opposite over the adjacent. So if I've actually made kind of a handout, and I'll put this on the assignment if you want to download it and print it. Right, here's SOH-CAH-TOA. Right here. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent, opposite over adjacent. Okay, so that's SOH-CAH-TOA. So this is how we would set this up. Now we can actually use this to solve for some missing sides if we wanted to, because we actually know the side relationships. Tan 75 will give us a decimal. So let's check this out. Okay, if I go in here and I go tan 75, it's going to give me this kind of funky thing, 2 plus root 3, right? So what we can do if we want to, as an exact, we're going to go like this. S to D will change this to a decimal. Okay, so the relationship between the two sides, between the opposite and the hypotenuse, is 3.72 to 1. What that means is this side is 3.732 times bigger than this side. In every 15, 75, 90 triangle, that's always true. If your reference angle is 75 and you're talking about the side that's opposite to it and the side that's adjacent to it, the opposite side will be this much bigger. Okay, that's what your calculator is telling you. Okay, so what we could do is we could replace this, right? 3.732 equals x over 10, and we could use this to find out what that actual side is, right? So if I wanted to get x by itself in this case, I could multiply both sides by 10. So I could take 10 and multiply it by this guy, multiply this guy by 10, and I get the length of x. Right, because these are going to cancel. So 37.321-ish is equal to x. So this side's about 37.32, right? It's much longer than this 10 side. Makes sense. It's a lot longer than it. Okay, so we can use these ratios to find missing sides because, again, tangent of 75, your calculator has that ratio stored. It has the relationship between these two sides given this reference angle. It has that dialed in, right? Just like you have these memorized, right? These relationships you know you could do off the top of your head. Your calculator has every other angle covered for you, okay? So I want to kind of go through those steps again with you, and I want to do a couple more examples that will help you get started on your homework. Okay, so the first idea is SOH-CAH-TOA. Okay, you gotta have to know that. Again, this is a memory device for memorizing it. If you don't have it memorized yet, you can print this out or you can write it out in your notes or whatever. But this will tell you the ratios. Okay, sine, the definition of sine for a given angle is the ratio of the side opposite to it over the hypotenuse. Okay, and similar for cosine and tangent. Right, it's just the definition of a ratio, so we have to know that. Okay, here are some steps that we can follow when we're finding missing sides of a right triangle. So we're going to run through these, and we'll do this with one of your homework problems as an example. Okay, so the first step here is to circle the reference angle. In your homework, there's going to be an angle that's not a 90-degree angle floating around in there, and you need to circle it. Okay, draw an arrow through that angle, and the arrow points to the side opposite the reference angle. Okay, let's do that over here in step 1. So we'll do number 2. Step 1 is to identify the reference angle. Okay, there's the reference angle. We're going to draw an arrow through it, and that arrow will point to the side opposite that angle. So this is the opposite side. Okay, I'm going to label it with an O. Okay, step 2. Label the sides of the triangle in reference to that reference angle. We already started that. Opposite, adjacent, and hypotenuse. Okay? So if this is the angle, the reference angle that we're talking about, this is the side opposite to it. Okay? This guy here is the hypotenuse because it's across from the right angle. The other angle is the adjacent angle. And notice that the adjacent angle is next to the 19-degree angle. It's actually it's like the side of the 19-degree angle. Okay? So I usually start with opposite, and then I go hypotenuse, and then the other one's adjacent. Right? Or you could start with hypotenuse because that one's pretty obvious. So let's label the one more just for practice. So in this case, I would say, okay, here's the reference angle. That makes this the opposite. Hypotenuse is across from the right angle. That makes this adjacent. Okay? So depending on where your reference angle is, your opposite side could be in a different position. It's all based on where that angle is, based on the reference angle. Okay, so that's step 1 and 2. Okay, step 3, determine the side length that you know and the side length that you want. So what we're talking about is, do you have the opposite and the adjacent, or the tangent and the adjacent, or the opposite? Sorry, that should be not tangent, that's hypotenuse. Sorry. I'll fix that on your copy. Okay. Do you have the opposite, the adjacent, or the tangent? You're going to have 2 of those 3. Okay, and you got to figure out what you're talking about. So in this case, notice that x is adjacent and opposite is 20, right? So the ones that I'm dealing with are adjacent and opposite. I still have h labeled, but there's no number or variable over there with h. Okay, so what I'm dealing with is the opposite and the adjacent. So I go there, this is step 4. I use SOH-CAH-TOA to choose the appropriate trig ratio, right? Sine, cosine, or tangent based on the sides. I just identified that I'm working with the O and the A, right? So since I have the O and the A, I'm going to use tangent. Tangent is the ratio that I'm going to use, the trig ratio. So I know this is going to be a tangent. Okay. Step 5, write and solve an equation for the side you want. Don't use your calculator until you've algebraically solved the problem. I'll explain that in just a second. But our equation we can do. Okay. So tangent of the reference angle, right, is equal to opposite over adjacent. So again, SOH-CAH-TOA. I know I'm using tangent. It's opposite over adjacent. The first one is always on top. The second one's always on the bottom. So adjacent over hypotenuse. Opposite over hypotenuse. This is opposite over adjacent. So for tangent, I want the opposite side, which would be 20, over the adjacent, which is x. Okay, so there's my equation. Now I can actually find out what tan of 19 is really quick. Like I'd be like, you know, tan of 19, and I could get that decimal, right? The problem though is if I'm going to write that down right here, I'm probably going to round it, right? And we don't want to round it yet because we're going to do stuff to that number. So we don't want to round right here. We don't want to round at this point in the problem. We don't want to round until the very, very end. If you round early and then you start using that rounded number, your number's gonna get thrown off. So we're gonna round at the very end. What we need to do is get x by itself, okay? And x is in the denominator here. So you can multiply by x on both sides, and that's gonna cancel. So now I have x times tan 19 equals 20. Now, remember, tan 19, the whole thing, this guy is just some number. It's this decimal, okay? The only reason we're not writing the decimal is because we don't want to round yet. So we're almost treating tan 19 almost as like a variable. We're just going to like do some algebra with it. So what I'm going to do is if I want x by itself, I'm going to divide both sides by the tangent of 19. Again, that's just some decimal number. I just don't want to like write it down yet. So I'm just using tan 19 as like a placeholder. So this is just a regular number. Well, it's an irrational, but you get the idea. Divided by itself, these are gone, and I have x left. So x is equal to 20 over the tangent of 19 degrees. Okay? Now we round. Sorry, I lost my train of thought for a second. Now we can round. Now we can actually get the exact value. So I'm not going to need to round it. I'm just going to go 20 divided by tan 19, and that's my side length. So I don't round it until the very, very end, but now I round it to the nearest tenth because that's what the instructions say. So this is going to be x is equal to 58.1 when we round to the nearest tenth. Okay? Okay, let's do a couple more because that's kind of tricky. We want to do maybe one of each and see a couple different scenarios. So I'll walk you through a few of these. Some are easier to solve than others, and it all depends on where your variable is. Okay, let's do number 7. Actually, let's do the even so that you guys have the answer to the odds. You guys can check yourself. Let's do an even problem. And let's do, a lot of these are tangent. I don't want a tangent. We just did a tangent. Let's look at the back here. Okay, let's do 14. 14 looks good. Okay, so let's go through the whole process. Find the reference angle. Okay, in this case it's 15 degrees. Draw an arrow through it, and that is going to point to the side opposite that reference angle. So there's the opposite side. Remember, it's all labeled in reference to the reference angle. Okay, this guy's across from the right angle. This side is across from the right angle, so this is hypotenuse. That makes this the adjacent side. Right? It's the side that's part of the 15-degree angle with the hypotenuse. Okay? All right, now the two that we have like labeled here is the 13 and the x, right? That's the opposite and the hypotenuse. So if I'm using opposite and hypotenuse, I got to figure out what trig ratio is going to go with those. I'm going to look at SOH-CAH-TOA. Okay? Opposite and hypotenuse go with sine. Sine is the trig ratio I need for opposite and hypotenuse. Okay? So sine of the reference angle, 15 degrees, is going to equal the opposite over the hypotenuse. Okay, this one's a little bit different from the other one because the x is no longer on the bottom. The x is on the top. Okay, we want to get x by itself. This one's actually going to be a little easier. I'm going to multiply both sides by 13. Now, remember, I can find sine 15, but I'm not going to do that yet because sine 15 is going to be this gross guy. Okay, so I'm not going to use that yet because I don't want to have to round it when I write it. I'm going to wait until the very end after I've done everything, and then I'm going to round. If I round too early and I multiply by 13, I'm going to end up multiplying my rounding error. Okay, so we don't need that just yet. We're going to multiply by 13. We're going to solve this guy algebraically first. So the 13's cancel here. So 13 times the sine of 15 is going to be equal to x. Okay, now I go to my calculator. Okay, so 13 times the sine of 15 degrees is this thing, right? Pretty ugly, so I'm going to go S to D, and that's going to change it to a decimal for me. I want rounded to the nearest tenth. Okay, kind of makes sense, right? 3.4, that's pretty short. This one's 13, it's longer, so it kind of makes sense in the picture. Okay, cool. Let's do one with cosine. So we're going to need an adjacent and a hypotenuse. Okay, let's do this guy, 13. Okay, start by labeling the reference or finding the reference angle. Okay, it's 18. Draw an arrow through it. Okay, that points to your opposite side. Label it O. Okay, the hypotenuse is the one that's across from the right angle, so that's H. And this guy is got to be the adjacent side. Okay. Oh, I picked an odd one. Sorry, I was just trying to pick one that had a cosine in it, so that's okay. All right, so which sides are we dealing with? Well, we got the 14 here and the x here, so we're talking about A and H. We want to find the trig ratio that uses A and H, adjacent and hypotenuse. Right? So we find A and H. Cosine is the one that uses A and H. And so we want cosine for this guy. So the cosine of that reference angle will give us the relationship between the adjacent and the hypotenuse. All right, if you think about it, every right triangle that has an 18-degree angle in it is going to have the same side ratios because all the triangles that are like this are similar to each other. Let's figure out what that other angle is going to be, just for fun. It's 72. So this is like a 1872-90 right triangle. Every 1872-90 right triangle is similar to every other 1872 right triangle by angle-angle similarity. So it doesn't matter what the side lengths are, the ratio of these two lengths will always be the same thing. And that's what this is giving you. Okay, let's just check out what that is really quick. We're not going to write it down because we don't want to round. But if I go cos 18, okay, what that's telling me is that the ratio between these two sides in this kind of a triangle is always going to be 0.95 to 1. So that's kind of cool. Your calculator has it stored. Again, it's kind of like knowing all these guys. Right? We have these memorized for the 30, 60, 90, but your calculator's got you covered on the 18, 17, 90. Okay, we just have to use that language. So the cosine of 18 is equal to the ratio of the adjacent side to the hypotenuse. Okay, so adjacent goes on top, hypotenuse goes on the bottom. Okay, so again, sometimes the unknown side will be on top of your fraction, sometimes it's going to be on the bottom. We have to know how to deal with both, which is why we're kind of talking about it. Okay, in this case, we multiply by 13 on both sides. In this case, we're going to have to multiply by x on both sides. Okay, remember cos 18 is just a number. It's this number, but we don't want to write it yet because it's ugly and it's long, and we don't want to round it just yet. But what we can do is we can consider that a number that we can divide by. Right? This is what we have left. So this is just a number. I'm going to divide by that number on both sides. Okay, now it's canceled out over there. So x is equal to 14 over cos 18. I'm going to go through and solve the whole thing before I go to my calculator. So this is equal to x now. This is all crossed out. X is equal to 14 over cos 18. Okay, so now let's do it. We're going to go 14 divided by cosine of 18. Okay, 14.7. And yeah, we're rounding to the nearest tenth there. So that makes sense, right? This is just a little tiny bit longer than this one. And it looks like, if this is such a small angle, then yeah, this hypotenuse and this adjacent side are going to be pretty close in size. All right, so this is our answer. Okay? So that should get you started. That's one of each. You're just going to follow that same process through in each one of them. Okay? This is the process. Okay, I'll link this, or I'll put this in the assignment if you want to print it out. You can also just write it down. But you need to use SOH-CAH-TOA, and you need to label everything correctly, right? One other thing that you got to keep in mind is that in order for this to work the right way, your calculator has to be in what's called degree mode. So if you're getting like the wrong answer, sometimes degrees are measured, or some angles are measured differently. So let's see if I can help you on this calculator. So shift, yeah. So if you go shift mode, you'll see that number 3 is degree and number 4 says rad. That stands for radian. Okay, so you want to make sure that you are in degree mode. If you are, you'll see, it's kind of hard to see, there's like a little box up here that has like a D in it. That means you're in degree mode. Okay, so that, you might have to adjust it on your calculator, but you have an answer key. You should get the answers on the answer key, and if you're not, it could be that your calculator is set to a different setting. Okay, if that's the case, we can kind of deal with that in class. You can shoot me an email. I'll see if I can help you out. But wherever you're at, whatever calculator you're using, you want to make sure it's in degree mode. And I'll put some information about that also in the description of this assignment. All right, I hope that helped, and good luck with your homework assignment. Don't forget about your quiz this week. It'll be a Friday for the A-Day guys and Monday for the B-Day guys. Thanks for watching.